Good afternoon, this is Schweitzer. I'm going to run a little video here on what a salt is and how it functions, what it means. A lot of the math we've already done, but just want to frame it in the idea of a salt, and let's give it a whirl. So what is a salt? Well, for the longest time, a salt, you think of it as table salt, right? But so NaCl, and by the FDA, the NaCl is considered like salt. Chemists would call it table salt, but really any salt in terms of chemistry is any ionic compound at this point. How would you make an ionic compound? Well, you just take an acid, which would be like HX, and react it with a base, NaOH, or some metal. Let's just call this a metal. So it'd be, why'd you do it again here? HX plus some metal hydroxide. And you're going to get some metal X, which this is now your cation anion, and you get water, HOH. So in this situation, the original definition of salt is now any primary ionic compound is considered a salt. Examples of these guys right here. So how do we know if these guys are acidic, basic, or neutral? Keep in mind, the only way these things can produce H plus and hydroxides is via hydrolysis. So you might think to yourself, okay, well, how can these things even produce H plus ions? Well, it's hydrolysis, so this is pretty straightforward. Now, the anion is a little easier to see, which is just X negative plus H2O yields H. So the cation has the ability to be acidic, and the anion has the ability to be basic, and that's going to show up here in a moment. So this is going to be HX plus OH negative. So you're basically taking a water molecule, and this anion here is grabbing onto an H, forming like HF, and leaving this guy behind, which is why it's basic. Well, how does an acid work? Now, this is a little bit different here. So this is showing the manual way to find a pH of a base, which we just did in the previous video. And I'm not going to walk through this whole thing again, but that's the manual way. Our goal here, we just kind of predict that idea. Okay, so how would an acid do this? Well, acid's a little more complicated. Still works kind of the same way, where we have the iron reacts with water, okay, and it forms what we call this little complex ion. It looks like that, which of course looks quite complicated. And then one of these H's sort of just jumps off and leaving like that, and then this guy kicks away here. So this is not something that, well, I shouldn't say that they're around. They used to be around, more common in advanced specimen chemistry, but just the idea of it is one thing we're just going to kind of hopefully have and introduce and keep around a little bit. In this case, so can I predict the range of a pH of a salt? So here's a spot to write down the next bit of notes we're going to use. And I might just kind of, well, let's look at this here for a second. So first of all, the way I start this, let's say, well, here's my notes here. I'm going to do NaCl here. So you can pause it here and I'll point a few things out here. I'm going to run through on my own. So NaCl, what acid and what base will yield the salt that I want? Now, when I walk through this thing like the long way, people quickly just start skipping around steps and go very fast. So what acid, what base yields a salt, and what water? By no means would you keep doing this long. So if I'm going to get NaCl, then HOH, we could unwind this reaction. NaOH would be my base. NaOH. H and Cl would be my acid. So in that case, keep in mind that this guy right here, important part here, that essentially, well, and this guy right here, okay, is that strong. You can pause the video and take a look at that. But essentially, this is a strong acid. Therefore, this cation, the conjugate of the chloride is right here. So this guy, the NaCl, has the ability to be basic. But because it's a strong acid, this thing is going to be neutral. So it flips over completely to being basic, but essentially very weak or neutral. All right, now this guy is a strong base, and then therefore this guy has the ability to be acidic because it's the conjugate of a strong base. And because it's a strong base, this guy also is neutral. So NaCl is a neutral cation and a neutral anion. And there you go. That's prediction. Now again, if either of these things happen to be weakly acidic or weakly basic, that means they would have to go through hydrolysis to get that result. Right? Hydrolysis. And we just talked a bit about those reactions. So there's the notes again. You can go ahead and you can pause and take a look. We do, however, have 4 combinations: weak and weak, neutral weak, so 4 different variations. And keep in mind that if you have a weak and weak, really, are you really neutral? Well, it's close. Really, the Ka of this guy and the Kb of this guy is who would really win out. So here's a couple of examples. You will have this one missing from you, but you can give it a try. So this is a weak base. How do you know weak bases? Well, the bases are really going to be determined by solubility. So we generally consider these first 2 families with a hydroxide to be somewhat soluble. Definitely the first ones are very soluble. These are our main ones here. I've seen these ones go both ways, so I don't know what to tell you. I generally consider them to be fairly soluble, but they do have KSPs, which means they really are not that soluble. But either way, really doesn't cause us too many problems. So let's go with this guy here, HCl, strong acid. This guy is a weak base, therefore a conjugate is a weak acid. Conjugate's neutral. Where are you going to see problems like this? Not like this. Actually, probably in a multiple choice situation. We're going to know, is it acidic, basic, or neutral? Who's responsible? The iron's responsible. This guy. Now let's go pause this one. Let's go much quicker. This guy is HCN. This guy is KOH. This guy is neutral. This guy is weakly basic. This is weakly basic. And that is our salt discussion. Okay. And thank you very much.